So on Unix, or in the Linux or Solaris or HPUX, the easiest way to achieve that is by running the Xvnc plugin. So the Xvnc is an implementation of X protocol, but without using a real GUI. And then Hudson has a plugin for Xvnc. So you still have to manually install the VNC server on all the environment that you're going to run it. But in most modern Unix systems, this is pretty easy. So with that, you could configure a job with the then the Xvnc plugin, by the way, you can, again, install from the update center. So you just need to click a mouse a few times and click the install button, and it will do it for you. And then once you set this up, then you could sort of you could configure the job that this job needs Xvnc support. And so what Hudson does is before we start running your build, it will launch Xvnc and expose the display variable to your build script so that when the programs run from inside your build script, they get automatically connected to the running Xvnc instance. And after the build, that Xvnc instance will be terminated. And I think it also has an ability to take the screenshots like at the end of the thing. So if you're running GUI test and that leaves the failure, you can sort of see it more conveniently. Now on Windows, it's supposed to be, again, it's easier. That is, on Windows, there is this concept called the Windows Station. It is somewhat like an X server in Unix, but it's a bit more sort of integrated into kernel. And then the Win_0 is the sort of hard-coded name for the interactive desktop that's given to the user currently logged in. But even the background processes that are launched by different users, in theory, gets a separate Windows station, the invisible Windows station. So every process in Windows, regardless of how you launch it, is actually have some window environment that they could run the browser in. Now that's the theory, but unfortunately in practice, this often kind of breaks because let's say like in IE, for example, right? The first time we install IE 8, it shows you the setup wizard. And then the IE doesn't know that it's running in this invisible Windows station. So it happily displays this dialog that no one can click, and it basically just hangs there. And then because you can't see those dialogues, you have no idea why it's hanging. And then people really get frustrated that they can't see what's going on. And so they either blame Selenium or they blame Hudson, and we have to sort of explain to them what's going on here. So in practice, what people often do and what I recommend is allow Hudson to interact with your real desktop. In that way, you can actually, so you actually see the browser showing up from nowhere and then showing dialogues and so on. So this will make it impossible for anyone to interactively use that build slave. But at least when things go wrong, you have a much easier time to track. So Hudson, when you deploy on Windows as a slave, gets deployed as a Windows service. So what you can do is to go to the the control panel and administration tools, and you could allow the service to interact with the desktop. And this is a magic checkbox that makes the service create windows in a way that you can see. Now on Mac, I think this is actually the worst environment as far as I can see, although I don't really have that much expertise, so I could be wrong on this one. But from what I believe, what I've heard from all the users, what's going on is that the user that runs Hudson needs to be also logged in to the desktop at the same time for any background process to be able to launch Windows. Otherwise, they'll just fail. Like the native application like Safari just fails to show window, and then it just breaks right away. So this sort of forces you to go into those slaves and log in. And then, again, those Macs won't be usable. And so this is a bummer, but that's how you appear, that's how you have to run these slaves. So, with this hopefully, these little bits of caveats, you could still run a reasonably good Selenium sort of grid environment on your Hudson cluster. But still, the installing the right browsers on the right machine could be tedious, especially once you start developing a fairly large number of clusters, or if you are particularly sensitive about providing a heterogeneous browser environment to run tests on. So it's always been a challenge or the tedious work to sort of make browsers available everywhere. So it'd be nice. We obviously thought that it'd be nice if you don't have to do that, right? And so that's where the source on demand comes into play, I think. That is, the idea is instead of asking you to install browsers on the cloud, well, you can just instead of forcing you to run browsers on the local machines, well, you can just start a virtual machine that's already pre-configured with the right browsers installed. So that's the idea. That is, this makes it even easier to get started because you no longer have to think about all these ugly, interact with desktop configuration or installing the right browser. And then you could also, because there are lots of different kinds of virtual machines are available, you get to choose the different browsers more easily. And then you just have to pay by the amount of minutes that you use. So that's a good part. The downside is that because those browsers are now running in the cloud, well, they can't really conveniently reach to your web app, which is running inside your firewall. So the way that this is worked around is by letting you set up this SSH tunnel. So you initiate the connection from the LAN to the cloud, and then the browsers connect back through this channel, and then that will talk to your web app. So that's how you can kind of make this whole thing work. Now, so that's the downside, and unfortunately, the setting up and tearing down tunnels is tedious on its own if you have to do it in every environment. And then another way to do this is, well, so instead of setting up and tearing down constantly, you can try to maintain a persistent SSH forwarding connection, but that's also kind of hard too, because now you have to notice that the connection went bad, and then you have to restart the tunnel and all that stuff. So as usual, I wrote the Hudson plugin to fix that problem, because Hudson doesn't mind setting up and tearing down the connections. So in this plugin, you'll specify the username and the access key, and then that will sort of register this information to Hudson. And during every build, you could specify Hudson to start the tunnel just for the duration of that build. So here's the basic tunnel information you'd specify, and then you run the build. So while your build is running, you got the reverse SSH port forwarding going on so that the browser on the cloud could access the web app you're testing. So I started using this. And one of the problems that I noticed is that the tunnel names, the tunnel is identified by a particular domain name, and then you tend to hard code this domain name in your test because that's the easiest thing to do. Like here, in the bottom line, the myapp.example.org is what the browser thinks is where your web app is running, which is actually in somewhere else, like the local host. But so if you do that, then if you happen to have, then what happens is you start to develop multiple branches of, let's say, the same project, and you'll be building those things concurrently. And they both try to set up the tunnel to this myapp.example.org, which fails. So this is not this is less of a problem if it's people that's running those jobs. But if it's a machine that's constantly doing those builds, it gets a real problem. So instead of hard coding those information, you can let the Hudson generate the host name for you. So if you do that, then the Hudson would be able to, Hudson would generate a unique random host name and then expose that information as the environment variable called source on demand host. So you can then pick that up from inside your build script, and then it will work. So I have a demo that does this here. So this one is a bit more involving, but so this is a test that I wrote.
Kosuke, you may want to move the window higher up on the screen.
Yes, thank you. And then let me also make the font a bit bigger. Yeah. So this is the bunch of configuration parameters that you have to specify to drive the browsers inside source on demand. But here, so I'm specifying the host name, as I mentioned in the slide, coming from the environment variable. And then I'm also specifying the browser type and browser versions in another environment variable called browser. So this is my trick to make this test runnable against different environments.